The National Electrical Code, specifically Section 410.67b, addresses the support requirements for luminaires, which includes 2x4 fluorescent fixtures. This section states that lamps spaced at least 4 inches on centers in wire shall be supported by the ceiling grid with threaded rods or other suitable rigid means. Where lamps are not supported by the grid, the luminaire shall be suspended from suitable aircraft cable or chain. This means that if the lamps within the 2x4 fixture are spaced at least 4 inches apart, which is typical, the fixture needs to be supported by the ceiling grid using threaded rods or another rigid support method. However, if the ceiling grid itself cannot provide adequate support, then the fixture must be suspended using aircraft cable or chain. The intent here is to ensure that the fixture is securely supported and does not pose a safety hazard by falling from the ceiling. Furthermore, Section 410.67c states that luminaire supports that attach to a ceiling grid system shall be adequately engaged with the ceiling grid structure. This means that any supports used to attach the fixture to the ceiling grid, including the additional ceiling wires, must be securely connected to both the fixture and the ceiling grid. The connections must be strong enough to support the weight of the fixture and prevent it from detaching from the grid. In the context of installing 277 volts fluorescent fixtures, the NEC requires not only that the fixtures be supported by the ceiling grid and screwed to the grid as mentioned, but also that the additional ceiling wires be installed at opposite corners of the fixture if the grid itself is insufficient for proper support. The requirement for these additional ceiling wires is implied in Section 410.67b, which mandates that luminaires be suspended from aircraft cable or chain when the grid doesn't provide adequate support. The additional wires serve as a supplementary support system to ensure the fixture remains securely in place. When installing these additional ceiling wires, firstly, ensure that the wires are of appropriate gauge and strength to support the weight of the fixture. Secondly, securely attach the wires to the fixture frame at opposite corners. Thirdly, attach the other ends of the wires to the building structure above the ceiling grid, ensuring that the attachment points are also adequately strong. Finally, make sure the wires are taut and evenly distribute the weight of the fixture, so that no single point of support is bearing too much load. In addition to the NEC requirements, local codes or regulations may have additional requirements for supporting fluorescent fixtures. It is always important to check with the local authorities to ensure that you are in compliance with all applicable codes. Some local jurisdictions may require specific types of wire or attachment methods for supporting fixtures. They may also have requirements for the spacing and number of support wires, depending on the weight and size of the fixture. Understanding and adhering to these requirements is crucial for ensuring the safety and longevity of the electrical installation. The reference to lamps spaced at least 4 inches on centers is a common characteristic of 2x4 fluorescent fixtures. This specification triggers the requirement for proper support, whether through the ceiling grid itself or through supplementary means like aircraft cable or additional ceiling wires. The primary purpose of these regulations is safety. In the event of seismic activity or other unforeseen circumstances, a properly supported fixture is less likely to fall, reducing the risk of injury or property damage. Also, proper support prevents stress on the electrical connections within the fixture, reducing the likelihood of electrical faults or fires. The NEC provides a baseline for electrical safety, and its requirements are based on years of experience and research. By following the NEC guidelines and best practices, electrical contractors can help ensure the safety of the public and protect property from electrical hazards. When interpreting the NEC, it is important to consider the specific language used and the context in which it is applied. The NEC is not always easy to understand, and it is often necessary to consult with a qualified electrical inspector or engineer to ensure that you are interpreting it correctly. The NEC is also updated on a regular basis, so it is important to stay current with the latest changes. Failing to comply with the NEC can result in fines, penalties, and even legal action. It can also increase the risk of electrical hazards and accidents. In addition to the specific requirements for supporting fluorescent fixtures, the NEC also has general requirements for the installation of electrical equipment. These requirements cover topics such as wiring methods, grounding, overcurrent protection, and equipment labeling. It is important to be familiar with these general requirements as well as the specific requirements for the type of equipment you are installing. The NEC also includes tables and examples that can be helpful in understanding the code requirements. These tables and examples can provide guidance on topics such as wire size, conduit fill, and overcurrent protection. The NEC is not a substitute for good engineering judgment. It is important to use your knowledge and experience to make sound decisions about electrical installations. If you are unsure about any aspect of an electrical installation, it is always best to consult with a qualified electrical engineer or inspector. The use of threaded rods or other suitable rigid means for supporting luminaires from the ceiling grid offers a robust and secure connection. Threaded rods, when properly sized and installed, can bear significant weight and resist lateral movement, preventing the fixture from swaying or shifting over time. The selection of appropriate hardware, such as nuts, washers, and lock washers, is crucial for maintaining a secure connection. Regular inspections should be conducted to ensure that the threaded rods remain tight and free from corrosion. When using aircraft cable or chain for suspending luminaires, it is important to choose materials that are rated for the weight of the fixture and the environmental conditions. Aircraft cable is typically made of high-strength steel and is resistant to corrosion. Chain should be similarly rated and protected from rust. The cable or chain should be securely attached to both the fixture and the building structure using appropriate hardware, such as clips, shackles, or eye bolts. It is important to avoid sharp bends or kinks in the cable or chain, as these can weaken the material and reduce its load-bearing capacity. The proper tensioning of the suspension cables or chains is also important. The cables or chains should be taut but not overly stressed, as excessive tension can place undue strain on the attachment points and the fixture itself. In situations where the ceiling grid is deemed inadequate for supporting the luminaires, it may be necessary to reinforce the grid or install independent support structures. Reinforcing the grid can involve adding additional bracing or supports to strengthen the existing grid members. Independent support structures can consist of beams, channels, or angles that are attached to the building structure above the ceiling. These independent structures provide a solid foundation for suspending the luminaires, bypassing the limitations of the ceiling grid. When installing additional ceiling wires, it is crucial to select wires that are of sufficient gauge and strength to support the weight of the fixture. The wire gauge should be determined based on the weight of the fixture and the distance between the support points. It is also important to consider the environmental conditions such as temperature and humidity, as these can affect the strength and durability of the wire. The wires should be securely attached to the fixture frame at opposite corners, using appropriate hardware such as wire clamps or connectors. The attachment point should be designed to distribute the load evenly and prevent the wires from slipping or pulling out. The other ends of the wires should be attached to the building structure above the ceiling grid, using secure attachment methods such as eye bolts, beam clamps, or concrete anchors. The attachment point should be located in areas that can provide adequate support for the weight of the fixture. It is important to ensure that the wires are taut and evenly distribute the weight of the fixture. This can be achieved by adjusting the length of the wires and ensuring that the fixture is level. The wires should not be so tight that they place undue strain on the fixture or the attachment points. Regular inspections should be conducted to ensure that the wires remain taut and securely attached. In addition to the NEC requirements, there may be other codes or standards that apply to the installation of luminaires. These may include building codes, fire codes, and energy codes. It is important to be familiar with all applicable codes and standards before beginning an electrical installation. Building codes may specify requirements for the structural support of luminaires, including the type and size of supports, the spacing of supports, and the load-bearing capacity of the ceiling grid. Fire codes may specify requirements for the fire resistance of luminaires and their supports, as well as the location of luminaires in relation to fire suppression systems. Energy codes may specify requirements for the energy efficiency of luminaires, including the type of lamps, the ballast efficiency, and the use of lighting controls. The use of qualified electrical contractors is essential for ensuring the safety and compliance of electrical installations. Qualified electrical contractors have the knowledge, skills, and experience to install electrical equipment in accordance with the NEC and other applicable codes and standards. They also have the tools and equipment necessary to perform the work safely and efficiently. When selecting an electrical contractor, it is important to check their credentials and references. Make sure they are licensed and insured, and that they have a good reputation for quality work. It is also important to discuss the scope of the work with the contractor and get a written estimate before beginning the project. The estimate should include the cost of materials, labor, and any other expenses. Regular maintenance of electrical installations is essential for ensuring their safety and reliability. This includes inspecting the equipment for signs of wear and tear, tightening connections, and replacing any damaged or worn components. Maintenance should be performed by qualified electrical personnel. It is also important to keep the area around electrical equipment clean and free of obstructions. This will help to prevent overheating and other hazards. The NEC is a complex and comprehensive document, and it is important to have a thorough understanding of its requirements before beginning any electrical installation. If you are unsure about any aspect of the NEC, it is always best to consult with a qualified electrical inspector or engineer. The NEC is not intended to be a substitute for good engineering judgment, and it is important to use your knowledge and experience to make sound decisions about electrical installations. The NEC is also updated on a regular basis, so it is important to stay current with the latest changes. By following the NEC guidelines and best practices, electrical contractors can help ensure the safety of the public and protect property from electrical hazards. The specific voltage rating of 277 volts further emphasizes the importance of proper installation techniques and adherence to safety protocols. Higher voltage systems can pose a greater risk of electrical shock and arc flash, making it crucial to use appropriate personal protective equipment, or PPE, and follow lockout-tagout procedures when working on or near energized circuits. The selection of electrical components, such as wiring, connectors, and overcurrent protection devices, must be carefully considered to ensure that they are rated for the 277-volt system and can safely handle the expected current loads. In addition to the NEC requirements, manufacturers of fluorescent fixtures often provide specific installation instructions that should be followed carefully. These instructions may include details on the recommended support methods, wiring connections, and grounding procedures. Ignoring the manufacturer's instructions can void the warranty and increase the risk of electrical hazards. The proper grounding of fluorescent fixtures is essential for preventing electrical shock and ensuring the safe operation of the equipment. The grounding system should be installed in accordance with the NEC requirements and should provide a low impedance path for fault current to return to the source. This helps to trip the overcurrent protection device and energize the circuit in the event of a ground fault. The grounding conductor should be properly sized and connected to the fixture frame and the built-in grounding system. The use of appropriate wiring methods such as conduit or cable is important for protecting the conductors from physical damage and environmental factors. The wiring method should be selected based on the application and the environmental conditions. Conduit provides the highest level of protection and is often required in commercial and industrial environments. Cable is more flexible and easier to install, but it may not be suitable for all applications. The wiring should be properly supported and secured to prevent it from sagging or becoming damaged. The connection should be made using approved connectors and should be tightened to the proper torque. Overcurrent protection devices, such as circuit breakers or fuses, are essential for protecting the wiring and equipment from overloads and short circuits. The overcurrent protection device should be sized according to the ampacity of the conductors and the rating of the equipment. It is important to use the correct type of overcurrent protection device for the application. Circuit breakers are reusable and can be reset after a fault is cleared. Fuses are single-use devices and must be replaced after they blow. The labeling of electrical equipment is important for providing information about the equipment's rating, specifications, and safety precautions. The label should be legible and permanently affixed to the equipment. The label should include information such as the voltage rating, current rating, power rating, and the manufacturer's name and model number. It should also include any safety warnings or precautions that should be followed when operating or maintaining the equipment. Regular inspections of electrical installations can help to identify potential problems before they become serious hazards. Inspections should be performed by qualified electrical personnel and should include a visual examination of the equipment, wiring, and connections. Any damaged or worn components should be replaced promptly. The insulation resistance of the wiring should be tested periodically to ensure that it is still providing adequate protection. The grounding system should be tested to ensure that it is providing a low impedance path for fault current. By following these guidelines and best practices, electrical contractors can help ensure the safety and reliability of electrical installations. The NEC is a valuable resource for electrical professionals, and it is important to stay current with the latest changes and interpretations. The NEC is not a substitute for good engineering judgment, and it is important to use your knowledge and experience to make sound decisions about electrical installations. In summary, the NEC Section 410.67b and C dictates the support requirements for 277 volts fluorescent fixtures. These fixtures must be supported by the ceiling grid using threaded rods or other rigid means. If the ceiling grid cannot provide adequate support, additional ceiling wires must be installed. Luminaire supports that attached to a ceiling grid system shall be adequately engaged with the ceiling grid structure. This ensures that the fixture is securely attached to the fixture and the ceiling grid, promoting safety and code compliance in electrical installations.